what mattered at the end of the day was, I think, number one, getting the architecture right, which is, Transformers was a good architecture. I'm sure there's a few more that we'll come up with. But more importantly, it turns out that what's important is the data compute and scale was way more important than that. And so what's interesting, for example, is that we don't talk about this these days, but AlexNet in 2012 was the major breakthrough for deep learning and neural networks. And without that breakthrough, I don't think we'll be where we are today.
What was your experience working with Andrew?
A PhD program in Stanford in 2009. So in the Stanford ML group, and Andrew was my advisor. The idea that these models could be trained and bigger. And I think as a student and subsequently as a person at Coursera working with him in the founding team, I think Andrew's superpowers are really just seeing that future that's coming and then taking big bets, right?
Nataraj is the host of Startup Project podcast. He is an investor at Incisive VC, an angel investor, and a product manager. All opinions expressed by Nataraj and podcast guests are solely their own opinions and do not reflect the opinion of the firms they work with. This podcast is informational purposes only and should not be relied upon for investment decisions. Nataraj and guests may maintain positions in the companies or securities discussed on this podcast. To learn more, visit thestartupproject.io.
Hey Ngiam, welcome to Startup Project, and thanks for coming on the show.
Thank you. Thanks, Nataraj. Glad to be here with you.
So I had to have you on the podcast. Your background is very impressive. You were one of the first employees and director of engineering at Coursera. You worked at Google in the famous Google Brain team. And you started, and I don't know if you've completed your PhD under Andrew Ng. And for the listeners who don't know Andrew Ng is sort of widely respected professor who pioneered Coursera, deeplearning.ai, and created one of the most famous machine learning courses, which I've taken in probably 2017 or 18. That was sort of like when I decided as an engineer. At that point, I was mostly software engineer. And I wanted to know, hey, what's happening in machine learning? What is this, cutting edge? I've never formally studied machine learning, but the go-to course was always, Andrew Ng's first course, and then he created a bunch of set of courses. That was like the source of truth for all us who didn't formally study machine learning but wanted to study as engineering, even if you wanted to pivot to data science and do more things around that. So yeah, really glad to have you on the show. But I wanted to ask about, what was your experience working with Andrew?
Oh boy, that's a question. Good question. Went way back there. So, a history here. So I started my PhD program in Stanford in 2009. So in the Stanford ML group, and Andrew was my advisor. So working alongside other people who are amazing in the field, like I think Andre was in the around the same time as me there.
This is Andre Karpathy.
Yeah, Andre Karpathy, Richard Socher, people like Andrew Mas, and there's like a really good set of people that were there. I think we were all very early into the deep learning space back then. And I think 2009 was a super interesting time when, if you turn back time and look at what we were doing, we were trying to train models on images to learn Gabor filters to see little edges in there, right? And it was just like at the beginning of understanding how this technology would work and could work and develop. But very clearly, there was a certain signs of scale is important, data is important, and the bigger the models is important. So working with Andrew was really amazing because, I think what's really cool about him is that he saw that potential, he saw that future way before it come to bear today, right? Yeah. So in 2009, that time, he was one of the first people in the entire ML community to really push hard on the idea of neural networks, the idea that these models could be trained and bigger. And I think as a student and subsequently as a person at Coursera working with him in the founding team, I think Andrew's superpowers are really just seeing that future that's coming and then taking big bets, right? And so it's like the big bet on neural networks in 2009, and subsequently, it's not an obvious bet, I
Yeah.
would say, back then. My friends were asking me, why am I doing this versus graphical models?
Mm.
And Europe's we were like the sideshow in some ways. But then I think we're all excited about the potential, and Andrew really pushed us there. And then working with him was really interesting in that he was someone who would push you to do more.
Mhm.
And I just fondly recall projects where you start off and you go like, okay, now you go to collect a big data set on your own. So like single grad student, figure it out. I set up my cameras, set up my data collection facilities, record it, and then collect my own data, run my own experiments, and some of these things, uh, from the outside, actually, it's kind of hard. To do any of these machine learning projects from scratch just
Yeah.
requires so much efforts because you're from ground zero, getting data all the way to training models and evaluating them. And Andrew was one person that's like, I think he'll push people to like just strive to achieve more and get more done. And partly me working with him subsequently became Coursera, where in 2011 we put out the first online courses in machine learning. I actually helped to design a lot of the programming assignments back then in Octave and got the team together to build the platform. And again, it's one of those things where building a new way to teach online is another big massive change. And in 2011, that was super exciting for myself because to see the ability to give people new superpowers through education was just very this just really heartwarming and very like mission oriented, which resounded with me. I mean, to say that about Andrew as well, I think in everything that he does, I think there's this aspect of him which is he wants to do things for the good of the world too.
Yeah.
And so you see that in him too as well. Yeah.
Was there any theory or thesis when you guys started Coursera that it would be as big as it is now, or even with deeplearning.ai, like was there a sense that it could become the go-to main platform for learning all this?
So I think at the time, we had our sights on like democratizing access to education, right? And if you turn back time to 2011, 2012 days, there were not many options to learn online, right? There were very few. In fact, the quality of materials online was very limited. I think MIT OCW, if you remember those times, that was
Yeah.
probably the best alternative then, right? There was no like assignments that you could do and get graded and get feedback on. None of that existed. And the only way to learn things was to go to college campus to really learn cutting edge things. And so when we started it back then, there was a clear sense in our minds that this could be a lot bigger than we thought it would be. Number one. Number two, I think is that the demand was very high, right? Because what happened there was that I think when we decided to do this, I think in a week or so, we put together a landing page and said, here's the course syllabus, here's a 2-minute video of Andrew speaking. If you're interested, just sign up. I just put it out
Yeah.
there. Stanford, I think, did an announcement about it. That certainly helped. And then we got tens of thousands of people signing up so quickly in just a matter of weeks. And so that just spoke to the latent demand for this
Mhm.
across the world. And then subsequently, after we got rolling on and did more, it became really apparent to us that the you know, the type of materials that we could make accessible, like machine learning, um, you at that point of time in 2011, 2012, you couldn't actually learn that at many places.
Yeah.
If you were to go to another college in a different country or a different city, they may not have the professors that could even teach the material. And if they did, it was someone who was like still trying to grasp and learn it too, right,
Yeah.
alongside you. And so that was really interesting to see that not only, like the demand for this was really big because of the lack of access to it, right? And we know that textbooks only go that far, and you need not just the materials and the educator teaching it and the assessment, but also the community of students. And then
Mhm.
that I think really came all together in like the idea of a MOOC, where it's not just materials online to learn, but people coming together to learn. And the forums were like lots of activities in there, lots of communication. I think that was like a whole. It was really nice to see all that come together.
Yeah. I think it was one of the first like serious online course I've taken,
Hmm.
which sort of like sticking to a schedule. I remember like which sort of you can, pivot your career with or seriously impact your career, sort of a course. And it's very rare that even today, I mean, it's also an example of internet generally democratized a lot of things, and for any given subject, you only need one good teacher or one good course, and everyone
Yes.
can use it, right? I think Coursera and sort of deep learning.ai sort of encapsulate that phenomenon to me, at least personally. Because if someone is good at physics, right,
Hmm.
pretty much every child in the world should be able to learn from the best teacher in physics. Right.
Hmm.
So I think internet sort of encapsulates that sort of a thing. So someone sitting in India could learn deep learning.ai, or someone in the US without, the hassle of getting a visa to the US, or, getting an admitted to college, and all these sort of barriers which exist. And you can, just get
Yeah.
past through all of that and just sign up and learn. So which is a powerful phenomena, I think. So you're doing all these amazing things, and then you no longer work with Andrew and move to Google Brain. So what was your experience there? Like, what were you building at Google?
Oh, that's a good question. Yeah. So I actually spent 7, 8 years of my life at Coursera helping build that out. Towards the end of it, I was actually like very interested to see if going back, we were doing a lot of technology like serving videos, quizzes, and everything. But I was always interested in like AI, right, machine learning. And around that time was when Transformers first came out,
Mm,
2017, 18 time.
yeah.
So seeing those papers, seeing the excitement around in architecture that could sort of generalize and work across a lot of modalities was super exciting to me, right? I think so. So after Coursera was trying to see where else, getting back into the field. So went to Google Brain, worked in the Brain team that had a bunch of amazing people, and then started to get into the field of like how do we apply AI to more places. And so I work on more of an applied team side where I worked with, if you find this like the Waymo team actually quite a bit. So a lot of
Mm,
papers with the Waymo group on point cloud recognition, 3D object recognition, figuring out how we can do self-driving cars better, from all the way from perception to reasoning and planning. So I did a bit of projects with them across the entire stack, and there was a lot of time I spent at Google Brain. Yeah, and then alongside that, it was just super excited to see like that's the whole time I think when we started to see the scaling laws come into place, right? And
mm.
then started to see like the team around me start to build out really large models to start to serve all these use cases. And it was I think an amazing moment actually. Like I said, I worked in AI for such a long time, machine learning, and we went from training very simple linear models like on neural networks, two-layer networks, and
Mm.
suddenly we're starting to see these models be able to generate and produce text and images and everything up there. And then on my projects, starting to produce models that could do like behavior prediction in different ways for self-driving cars too and all of that. Yeah. Hmm.
Um, so I remember this distinct feeling when
Yep.
I forgot if it's in the course itself or some other place, when you first do a simple project of recognizing letters, right? I think
Hmm.
that was one of the first exercises I remember doing. You feed a bunch of images of English letters and try to create a model that recognizes just those letters. And I felt like thinking that this is similar to how a human brain sort of works, but it's not exactly how it works.
Hmm.
Um, I'm curious, did you have any that sort of like comparison going on in your mind on how you think about these neural networks, or, now large language models, and what it means when you compare it with human brain?
Oh yeah, that's certainly. So I think a lot of the design and concepts of neural networks were inspired or brain inspired, right? Um, I think for myself, I think what's interesting for myself is like we when we were thinking about the ways to approach this, and it turns out that maybe the lesson that we learned, like I see is what mattered at the end of the day was, I think, number one, getting the architecture right, which is
Mm,
Transformers was a good architecture. I'm sure there's a few more that we'll come up with. But more importantly, it turns out that what's important is the data compute and scale was way more important than that.
mm,
And so what's interesting, for example, is that we don't talk about this these days, but AlexNet in 2012 was the major breakthrough for deep learning and neural networks. Without that breakthrough, I don't think we'll be where we are today.
Okay, can you explain to the audience what that breakthrough was?
Yep. So back in the day, this is ImageNet 2011, 2012 days, where the task was to classify an image into 1,000 potential categories, right? 1,000 categories. And so like, is it a dog of this breed? Is it a cat? Is it an aeroplane? All of that. Very hard task. Up to then, the state-of-the-art methods, could barely get 10% or something like that. It's very single-digit percentage, like really hard task to do. And then there was 1 year in which Alex Krzyzewski from University of Toronto, Jeff Hinton, and Ilya, definitely, came together. Then what they did was fascinating. They took
This was Ilya who started SSI yesterday,
right.
which announced funding for $1 billion.
Exactly. So this was like way back stories in there, but they took convolutional neural networks, which is a concept that was been around. Like Yann LeCun came up with it way back in the 90s, I think, and they just scaled it up. Right? They just took that model, say make the filters bigger, make more layers, put in a lot more data, train it for longer, just make it bigger, right? And then did a lot of work down around compute, because making it bigger was not easy from a training perspective. You get to wait a long time for the train. So then they also take like 2 GPUs, and then Alex was figuring out how to make custom kernels around them to train such a model. And then the breakthrough happened in that approach, take a existing known approach, convolutional neural networks, scale it up, just blew through the water, right? Just blew out all the metrics, blew out all the performance, and became the best approach there. And subsequently, we had all these other approaches like residual networks, ResNets, we had inception nets and all those things. There were variations and modifications on this base idea there. And that really to make the whole deep learning field take off in the image processing, image understanding regime. The next takeoff, I think, happened during language, where we had RNNs and then memory RNNs, and then after that, transformers come from that. And then I think that's the next takeoff in there. But in both cases, what happened was we found a architecture, convolutional neural networks or transformers that worked. And then what the secret there was, how do we scale it up? How do we pour as much compute data into it as possible? And just keep pressing that button to scale it up. You get better and better and better results, right? So to me, I think that was while many things were brain inspired to begin with, what was more interesting was the ability to scale up compute was way more important. So it turns out that the methods that fit the compute paradigm better. So if you implement something that fits, the CUDA or TPU architecture well, then you could scale it up better. So it turns out that methods that were amenable to scaling and partially, limited by, how we design our hardware, those work better, right? So that's actually fascinating to me, at least, to see that was the real reason why the things are working. Yeah.
When even to your point of scale, right? Even like from GPT-2, when no one was looking, like only the nerds were focused on GPT-1 and GPT-2, and suddenly GPT-3 and when ChatGPT came, like everyone started seeing the scale, right? And with every new version of new model from Llama or any other company, sort of like the improvements are pretty significant.
Yes.
What do you think? Like, how are you thinking about like when it's the next scale shift? Like, is GPT-5 going to be a scale shift? I know like the parameters are now at what, trillion or more, right? So do you see like a significant change, or is it going to be like 4 to 4.5? And how might that look like? Do you have any idea?
It's hard to tell. I can give my unpopular opinion, maybe.
Yeah, go ahead.
I think my popular opinion is that the GPT-4 are definitely in the trillions of parameters, right? But there is to scale it up more, you need not just more compute, you also need more data. Right? And data is one that I think is going to be limiting us, because we've kind of exhausted lots of data sets to train these models, especially in the language part of it, right? Now, we could generate more synthetic data, but synthetic data is going to be as good as whatever you generated, what's a generator for it.
Yeah.
Right. So you're going to fit the generator, not the real world, right? And then if you think about that, and also like say you need more compute and the order of magnitude of compute, you start to get a point of like diminishing returns, right? So while
Yeah.
most people think that we are maybe on an exponential curve to progress, my hunch more and more is like we are more on like a sigmoid curve, if that makes sense,
Mhm.
where we're
They're
progressing,
flattening
so
out.
going up, and after like, oh man, the next incremental progress is harder and harder and harder, and
Yeah.
eventually we flatten out because we have run out of data,
Yeah.
right? Now we can self-play and do that stuff and all, but again, that's a lot, needs even more data. So like, I think we might be at that curve where incremental quality improvements is going to
Yeah.
be harder moving forward. There's a little bit, I mean, it's been more than a year since GPT-4 came out.
Yeah.
And honestly, we haven't seen a model that is significantly better than what came out in March last year, right, publicly. Right. We
Right.
think what I can be confident in, on the other hand, is that I'm pretty confident that the cost will go down and speed will be better. Like very
Yeah.
confident in that. In fact, I think we are finding out more and more ways to take these big models and distill them down into smaller models that are very effective to serve, right? So the
Yeah.
GPT-4 series of models, I think were all derivations of the original GPT-4 model, right? So we're just finding out ways to make it smaller and smaller. GPT-4o mini, for example,
Mhm.
recently, to make it serve really high quality models at a very low cost and very high speeds, right? So I think that's what's going to happen there, and that's going to be really interesting to see, right? Because there'll be this effect where the goal is to train a model as big as possible, but you don't want to serve it. You want to use
Yeah.
it to generate data to train a very small model and then serve it, right? So
Yeah.
that's to be kind of the game moving forward, I think. Yeah.
Yeah. I mean, I sort of tend to agree with you. And to your question of like not having enough data, right? I also think that's also a limiting factor in some of the use cases that we want to unlock. For example, like everyone wants to build a personal robot these days.
Mm-hmm.
Like Tesla has an initiative. You've seen some other new companies. I forgot the name, like 1X or Feature. So there
Mm-hmm.
are companies that are building like, general robots which do housework or some other work. And I think the limiting factor there is data. Like there is no data of me folding clothes, continuously of different types of different kinds and different
Yep.
households, right? So for it to do, so you need almost like a scale AI like company, which is generating this type of data and labeling it. And you can take this example a little bit, stretch this out, and there's no data of me doing work in my backyard. So the robot cannot do that work or learn how human does it. If you want to replicate a human sort of behavior, you can extend this beyond like picking apples in a farm. Of course, that we have solved in a different way without doing it in the same farm as a human does. But if you want to really replicate a human-like activity, we don't have that data, and have this ridiculous idea of like just like how we've cameras for monitoring the police behavior. Like every police these days wears a camera on them, right? So that everything gets investigated. If you really want to get these use cases going, you need to offer people money to put a camera on themselves and
Mm-hmm.
record these mundane tasks while they're doing it. So, for example, you put a camera on a McD worker in a McD and how they're flipping burgers. You put that across 100 of McD workers, you got a perfect model that you can sort of learn from it. So this is like a little bit of a out there idea that I have in terms of unlocking some of these use cases which we don't have really data about. And that's what will limit these things. And I think synthetic generation of this data, I don't know how much effective that is yet, but that's one out there idea
Yeah.
I was thinking about.
That's interesting they mentioned that because I think maybe when I think about data and what you're learning, I actually think of it as like also not just the data, but also like what is the signal you're getting from the data, right? So for example, we know that data from code, software data, is really powerful because
Yeah,
your code contains lots of logic. It contains reasoning in there, like the formal reasoning. Code is almost like formal reasoning, writing down, what do you want to do in an expression, right? Software.
yeah,
And so there's a lot of power in software code that we can learn from. But
yeah,
then if you take data like from McD's worker, right, flipping burgers, what you're learning there is not reasoning. You're not the reasoning, but you're going to learn about physics. You're going to learn about the burger. You're going to learn about when's it cooked, when it's not done. The image, how it reflects that in the image, and how you see it. You
yeah,
learn about the activities they take. Now they flip the burger, and after that, are they going to put it on the bun? What are they going to do? Sequential activities, much less reasoning activities, but more physical world activities, right?
Yeah.
So I think right now we see like a lot of new image models, video models are coming out, and I think what we're starting to see is like we kind of done a lot of reasoning work to learn about reasoning models,
Mm.
and now can we learn about the physical world? Can we model the physical world implicitly in these models through pixel data, right?
Mm.
And maybe what's interesting in here is there's an open question of like, can we connect all the pieces together? We have the reasoning world that we learned, they have the
Yeah.
physical world that we learned through the visual data. Does it allow us to take that reasoning data that we learn, our reasoning data databases, and then apply it to the physical world? Right. So I think there's some projects in Google just around the time when I left, like SayCan and everything. We're trying to connect the dots in there to make that happen. And so it'd be interesting to see if can we take all the data from language models and make robotics go much faster. Now, I think what happens here is that the limiting factor for us would be like making reasoning even better than that. It's going to be hard. But then reasoning will get better at reasoning about the physical world if it had the physical world uh, information from videos and all. And the physical world information, like flipping burgers and all, would be informed by, reasoning data. Like, if there's a lot of text on physics on like, now you
Yeah.
know what the cat is and the tables and everything, you know that objects don't go through objects. That might influence how your model decides to interact with the world.
Mm.
Yeah, stuff like that though. So it's really interesting to see like the, the composition of knowledge come together, and maybe there could be something there that
Yeah.
unlocks things. Yeah.
Yeah, I think the next unlock is around this
Yeah.
sort of like phenomenon. I think that's another shift we are about to see.
Yeah.
But moving on, you worked at Google, then you started tinkering with your own company, and now you launched Lutra.ai or about to launch. I've seen the demo; it's pretty mind blowing. Uh, Tell the audience, what is Lutra.ai? How did you come up with this particular problem to work on next?
Yeah, so it's great. So Lutra AI, think of it as, I guess agentic AI agents, but then really for knowledge task, right? So we've seen a lot of AI agents for coding. This is for you to help you in your daily work, like, you maybe do a lot of internet research, maybe you're Googling for things, maybe you're working through spreadsheets and you like AI to help you, assist you with those things, right? And eventually delegate a lot of your tasks to the machine. So that's what Lutra AI is about. So it's a AI that's natively integrated into the app you use, understands how to use them, understands how to get data and how to manipulate data inside those apps in there. Yeah. So the genesis of it actually came from, when we started to look at language models and these new set of AI models, we started to see that they had really powerful reasoning, planning, and coding abilities.
Mm.
And what was missing from them was really what is the right environment for them to operate in. What's the so-called arm and legs, to give them so that they can do stuff around the world with them. And so where we focus at Lutra is that we're starting to think really hard about the optimal ways to attach all these applications into an agent and let it be able to reason, plan, and code and to manipulate the environment around it. In this case, the environment are the applications and software you use, right? And so that's kind of what we're building there. And so we're incrementally making that seamless experience where you could go to it and say, in fact, here's an example. I actually have Lutra plugged into our production database at Lutra itself. So sometimes what I do is that I ask Lutra, hey, tell me who signed up for Lutra in the last 3 hours or last 3 people signed up. Tell me a bit more about them. Okay, cool. I want you to reach out to all those people, and then say thanks for signing up. Would love to learn more. All of that. Or maybe tell me about activities they're doing. Go and pull all the anonymized activities that people are working on. Summarize what are people trying to do on the platform today. Give it to me, right? And so rather than me having to go and figure out how to get the data, write the script for it, I can just ask Lutra to figure that out because it's just plugged into my ecosystem. Then I can say, okay, generate a report, make it a Google Doc or Slack it to me, and then it also knows how to use those software, so it's able to connect into there and send it to me, and that just makes a lot of processes, a lot of things that we do at work just more streamlined, right? And so it's really good at like just pushing data, using AI to understand it, and also looking at web data to work with that as well. Cool.
So you're actually, when you're taking that example of, hey, tell me all the users who signed up and what they're doing on the platform, what you're doing behind the scenes is generating code
Mm-hmm.
to achieve those tasks, right?
Yes.
So are there any different approaches other people are taking when they're saying they're building agentic AI, or is this sort of like the common approach?
I would say this is not the common approach actually. So the common approach has been more of a what they call a React-based or often a function calling based
Yeah.
approach. And the main kind of difference in there is that how do you work with the language models? What context do you give it? It's very open up ended to developers like myself to figure out how to work with the language models. The common approach is to give it all the data. Like, hey, I read this document. Here's the whole document. Tell me what to do next.
Mm.
Right. But what happens there is that the issue there is that it quickly goes a bit, like number one, the token windows quickly get blown out because like documents can be long. But number two, it quickly might also go off the rails because it starts interpreting what's in a document as actions that it might want to do, right? It gets over influenced by the content itself. So what our approach is that, we want to see, can we more cleanly separate out data and logic? So the model understands when it's taking actions on data and what the outcomes are. And the model also understands that there is data it's working with. And this is where it's looking at data, summarizing, extracting data from it, but not having the two threads of thoughts be too confounded together. And the more you confound it, the harder is it to create agentic solutions that are reliable. And so our approach is a bit different in that way. Yeah.
One of the things that you said in our conversations while talking about the product is that you were using, different LLMs for different purposes
Yes.
behind the scenes. And talk to me a little bit about that and which LLMs are doing what better and why are you using multiple LLMs? I know like a lot of products are sort of making themselves sort of redundant in spite of the back in which LLM they're calling. There's sort of like a business reason, there's a cost reason per se, but just purely in terms of like the product that you're trying to develop, like what is working with which LLM?
No, quick question in there. Yeah. So it turns out that the LLM space is a fascinating one, and it turns out to be very easily swappable now. If you use the OpenAI spec on things, you could swap between any model provider very quickly. So what's different is actually the models and what they provide. And so and I think the clear ones are like model sizes. Very small models like Haiku or 4.0 Mini are very cheap. They do well at certain tasks like summarization, writing tasks, sometimes data extraction tasks, but they do really poorly at reasoning and planning, generating software code, deciding what to do next. And then when you go to the bigger models, they are slower, but they tend to be much better at some of those aspects of reasoning, planning, coding, and so on, right? And so it really comes down to the task you're doing. And so we think of a task in Lutra as just definitely the reasoning and planning part of it. There's like the writing part of it, summarizing articles, creating drafts. There's the data extraction part of it, given a document, extract data from it. And then there's also another one is like classification. Figure out what, given a topic and I'll classify something, right? So those are the like concrete key AI aspects of things. And so we evaluate the models based on some of these aspects. So obviously for the big ones, the biggest models we use for the reasoning planning things, we figured out evals for that. And for each of these tasks, we have different evals for them too. Yeah, and then personally, I like the way anthropic models write. So we also use mostly of the Claude models for writing things too there too.
And what are you using for code generation? Because I think recently Cursor and Cursor, I think, uses by default Claude's Sonnet model, I think.
Yeah, so Sonnet 3.5 is heads and shoulders over everything right now for code generation. So if you're doing any code generation, you should absolutely use Sonnet 3.5 today. And I think it's the default model in Cursor as well.
And why is that? Is that because they primarily trained on the code, or why do you think it's better?
Oh boy, I need to ask my friends at Anthropic for that one. But my hunch is that, some of these model series are probably like, distilled versions of the biggest model. That's my imagination.
Yeah,
And
they
then
just like put only code into this versus like code and everything
yeah.
else into other one.
So my hunch, like, my guess, right, is that they take the big model and then they distill it down using a lot of code examples
Yeah.
to the small models, and then they experiment with that. And they're just having to train a model that's lots of code in Sonnet 3.5 there. But I would say training with code is actually really good because we have seen that code makes models better at reasoning. So it's actually it's actually a great thing to do there. Yeah. So, but I think at the end of the day, the evals are probably what you want to look at. And I think the evals are pretty solid still. But they do give you a good signal in comparison in model quality.
Are there any you know, evals is basically how you evaluate. Eval is short from form of evaluation, right? What when a new model comes out, what are the evals that you are looking at?
Yeah, so I mean, we definitely look at like the public leaderboards like LMSys and everything. LMSys also has breakdowns into different categories there, so that's a quick way to get a sense of things. Internally, we have our own eval sets. So for example, I mentioned data extraction with a eval set that's like, okay, these are all the data pieces, it ran this model with the setup, does it get the right data out of it, right? Then there's some like very natural precision recall type metrics you can get from that. Then there's also like end-to-end eval sets, because we are doing like orchestration of tasks. So given this task to start, is the model and the rest of the system able to get to the endpoint successfully, even though it encounters difficulties in the middle, right? And so sometimes we do end-to-end evals as well when we when we do prompt adjustments or when we do model changes. There.
Got it. Any thoughts on like Cursor and the whole AI code generation? I know it's I mean I've personally used it, and I was thinking of writing a script, a pretty complicated automation script in my mind for a long time, last couple of weeks, and suddenly this Cursor sort of came into mainstream, and then I downloaded it, and I'm already familiar with VS Code, so it's a version of VS Code, so that makes it a bit more easier to work with because developers are usually sticking to their own IDEs, right? So I mean, I was able to do that script, maybe within 2.5, 3 hours, and it because I'm not actually developing in my day to day. It's actually pretty good in terms. It would have probably taken much more, and I would have phased it out in a couple of days, and things might not be working. I would have probably spent more time debugging it, because I'm not writing code that regularly. I might have gone wrong with syntax, or I might not handle errors correctly, or all of those routine things could have happened. But with this, it was less writing code and telling what to write and sort of prompt, verify, iterate, prompt. It was so I was more prompting than actually writing, but I still had to understand the code because then only I can actually execute it and see if it's actually serving my purpose. But I felt like it is like a superpower for the average person. For a good coder, it might not be. Even for a good coder, I think he will, get a time benefit out of it. But I consider myself as a very average coder, and for me, it felt like a superpower. Especially, I think in the bracket I am, where I'm not coding, but even people who are actively coding, not everyone is like really good at coding, right? That doesn't come naturally to them. You see this in organizations differently. Like someone is really natural at it, and someone is like, hard worker at it, right? Someone is the example I give is, someone has H100s and someone else has like 100 Intels that he wants to train the same model on. That's my hard worker, so like that's smart work analogy these days. So it felt really powerful, like, and I think we are seeing ideas with AI is like you take an average X and you can take and give them sort of 2x, 3x powers. Like you take an average accountant, you can make them probably a little bit better.
Yes.
You can take an average coder and you can make them a little bit better. You can take an average Adobe creator and make them a bit better. All right. The same prompt, adjust, reprompt sort of cycle. I'd love to know what your thoughts are around it.
I actually think that it's both ways actually. Like I think the way I say is that it raises both the floor and also the ceiling. Right, so the average person on the floor of it, like everyone can now do something. Like I couldn't do a lot of illustrations. I can just get models to illustrate for me, but it's not that good, right? But then I think if you ask professionals to sit down and use it, and they start to get a lot of inspiration, and they can go further from it. So I think both the floor and the ceiling gets raised. Myself and our team, I'm using Cursor myself, my team too. So we're all using Cursor right now, and we used to use VS Code with GitHub Copilot actually, and Cursor was a better experience, honestly. And the main part for me is actually that Cursor translates my thoughts into code much faster. So I kind of know what code I want to write, rather than having me like manually like typing in the keystrokes. I just need to verify that the model agrees with me. So it takes me, the way I use it is that my team uses it. So you go in there, you prompt, and then you kind of know what you wanted to do. You tell it, and then it just does it for you, right? Now, I think where it gets tricky is that sometimes these models don't do the right thing. So one time it deleted half my file without me knowing, and I was like, "What happened?" And I couldn't figure it out. One time it messed up my imports, and you gotta fix that up too. Sometimes it does, a bit strange things. Sure, that will get better. But I think the superpower is that if you know exactly what you want and the model is able to predict it very well, you can work really fast. It's just like tap, 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 tap.
Yeah.
Everything just comes out very quickly, right? If you do not know what you want and you're just like guessing at it or you're not really familiar with it, it's still very powerful because it gives you a first draft, right? You can validate and see whether it makes sense and everything, and then you can go from there. So in all cases, I think it's a super accelerant in our internal, our working processes and how we do things as well. Yeah, so I think it's been interesting. But I think it's not just Cursor, but just the whole Copilot experience in coding, I think, is the main one. Because we have been also using GitHub Copilot before Cursor over there. Yeah, but yeah, that's
Do
one
you,
thing.
do you think, I mean, I haven't used GitHub Copilot almost for a year now. Do you think like whatever Cursor is doing is replicable in GitHub Copilot pretty fast? Because that's what the feeling I'm getting, even though Cursor is impressive.
Yeah,
Um,
mhm. I mean, the two things in there, right? I mean, like the models are going to be commoditized. So,
yeah,
Sonnet 3.5 level coding abilities will come to all models soon and be
yeah,
fast too. And number two, I think, is it's just all UX. And UX you can see, you can reproduce, you can copy it,
yeah,
So there's not, I don't think um, there's so much there that you couldn't actually bring into VS Code, GitHub, and so on, things in there. It's my point of view there. Now, I think what's interesting is some of the UX patterns that we're seeing are very new,
yeah,
right?
I
So,
agree.
for example, how do you do a multi-location edit and show that to the user in a way that makes sense, that's natural for them to tap through and complete it? Because edits are not only in one place,
Yeah,
right? How do you do a multi-file edit to say, okay, I need to make this change, but it's a multi-file thing? How do I even
yeah,
show the user that experience? How do I walk them through what's going on and make it go, right? Some of those things are going to be a bit new from an experience point of view that we need to figure out the right interaction patterns.
yeah.
And I think that's still pretty early in like figuring that out and what it is like. So yeah, I think there's a lot of space to explore there. Yeah.
Yeah, I definitely agree on that. Like, I think it's more, there needs more innovation on like user interactions and how do you
Yeah.
guide through and make it more productive. I think that's where a lot of innovation in Cursor is sort of can be attributed to.
Exactly.
And Cursor is even more powerful um, if you know exactly what stack you use already. Like if you have a repeatable stack that you're already sort of good at or sort of use and sort of know ins and outs about it, or even have like a 30-20% knowledge about it,
Mm.
then it's a game changer for you. That you can replicate that stack because everyone has like a full stack sort of
Exactly.
they usually work on it, their back and their front end. You can just churn new MVPs now, with very limited amount. And you can do that with like if you're an iOS developer with iOS apps, if you're an Android developer with
Yeah.
Android apps, even with apps on like Shopify or WordPress, which are very common knowledge to the code already. And that makes it even more powerful. And Python scripts, obviously, because, I think the models have lots of Python data. So that makes it even much more powerful if you're just doing Python scripts. So yeah, I mean, it's a great time to write some code, I guess. Uh,
No, it's good. I mean, it's an interesting time to be an engineer because you can be very
yeah,
productive with very little there. Yeah, I think so too.
yeah,
But I
yeah,
think and then there was one time I read was it ChatGPT or GPT-4 did make a bug in one of my code maybe a long time ago. Then the challenge is then when that happens, sometimes it's very hard to hunt down
yeah,
because when you write everything yourself, you kind of have you grok everything, you know what there it is. But then
yeah,
there's one time I think the model made like a very subtle error in some comparison, and it took me a
yeah.
long time to hunt it down. So, it'd be interesting to see what happens in the future. Maybe everything will be more accurate and good and be fine, but you might also be in a situation where very subtle bugs become very hard to find and fix.
Yeah, yeah.
Yeah,
You need to find that abstraction level at which you want to write,
yeah,
want the model to write code. Or maybe like small function, write a unit test by the function, then verify it and then generate it instead of like going wholesome and generate an MVP out of
yeah.
cloud.
That's right. That's right. Because
Right. So
ultimately, these models serve a user, right? Like these things are not like, oh, I'm just gonna do everything independently. Like there's a user directing it at some level,
yeah,
either at a task or a specific like function level or something, or even higher level, like the goal. And I think that's to keep in mind, like that the goal is to serve the user, to serve the need of that user in there, and helping to achieve that goal. Right?
Yeah.
And
I
it's
mean,
easy, sometimes easy to think about the AI is just doing everything on its own, but it's really more helping someone at the end, right?
yeah, yeah.
Yeah.
I mean, you're working on agents, and you brought up a really good point about like there's always a human, because there's always the stock of there's EACC movement, and I forgot what it's called actually, acceleration of AI essentially, and then there's a deceleration movement, and who think that AGI will not come anytime soon. What is your thoughts on, are we close to getting AGI? OpenAI famously says their goal is to sort of
Mhm.
bring responsible AGI, or I'm paraphrasing, but some similar to that. What are your thoughts on this whole AGI? Are we coming close to it? Do you even can imagine it? For me, like I can't imagine with the existing models that we are at AGI. I can see that we can see a lot of agents doing work and agents getting better, which might look like it, but not really being AGI, right? So I'd love to get your take on it.
Yeah, no, it's a good question there. I think like sometimes how you define AGI.
Yeah,
If you
yeah.
define AGI
Everyone
as
has their
like
own definition of AGI too.
exactly right, and if you define it one way, it's like, oh yeah, it's here. If there are another way, it's like we're very far from it. Like it's like they're doing all skilled labor that or
Yeah,
knowledge labor that we can do. Like no, it's not there yet, right?
yeah.
And I think it's like sometimes I wonder if the right question because of the lack of like very clear definitions of that term. I think the conversations tend to become very confusing to
Yeah.
me at least. And like we're kind of like talking past each other sometimes when we talk about that. But I think what's really more interesting to discuss is like, hey, what are the set of tasks, maybe knowledge
Mm,
tasks in this case, right, that we can start to delegate to computer. Now, clearly we can delegate a lot of root writing test code. You've seen that models can do that very well, right?
yeah.
We can delegate generating a first draft of application. Lutra, we're trying to delegate more and more tasks. Like, you want to do some web research thing, get it into a spreadsheet, just tell the computer, you can do it now, right?
Yeah.
Now, then I think the scope and expanse of that kind of task you can delegate slowly starts to grow, right? Initially, it's like working with a few applications, initially just working with like getting some data from one system to another system or making one script for you. And then eventually like making two scripts for you, doing three applications. And so it has to grow into bigger and bigger scopes in there,
Yeah.
right? And maybe what's more interesting is just looking at that because the impact to society and impact to us doesn't need to come where AGI comes. It can delegate the biggest task, which is, make money from it, something like this, or, whatever you want it to do.
Mm,
Um, it might come way before that, where we can delegate a lot to start to the computer,
mm,
right? And then I think that's really interesting. Like today, if you don't use the models to help you in writing, in drafting materials, that you're behind, right? You're not delegating that potential first draft away or ideation to a machine that could really help you in that process. Now,
yeah.
I think there's ways to delegate it that you benefit from it, and ways to delegate it that you don't benefit from it, that you over delegate it. I think that's kind of like how I think about it, right? Which is what tasks can we delegate? What skill can we get? Skill of tasks we can start to do, and start building
Mm,
up from there. And then I think that brings us to a kind of like a point which is, you want to start probably with like the very repetitive manual things,
yeah.
right? Like all the things that we do not want to do as people, like clicking around mindlessly on the website, copying and pasting things, shuffling data around, sending the same reply to our customers 10 times because it's the same questions. That's not there, right? That's not there because that's not the parts where it require us to do a lot of creative thinking or make critical decisions. Now, as you go up the hierarchy, then you start to see less and like more and more things to get there. But what I hope is that uh, what I see is that it's really hard to get all the context and nuance of who we are as people into a model. There's so much context in our lives, our histories that the models don't have, and our preferences. So a lot of decision making, I think, be very hard to delegate to a machine.
Mhm.
Right? We can tell it our preferences. Maybe you tell it our preferences and like how you go on a travel or trip, flights and everything. You can do something micro like that. But for it to do more detailed stuff for you, like plan out a romantic weekend with my wife. Like you kind of want to do that because there's so much, you know, nuance in there and context in that it doesn't have, right? Like moments in time. So thinking about that is like in a business in our day-to-day lives, like I kind of think of it in that framework, which is what can we delegate today? What do we
Mm,
want to delegate? And what are the things like decision making type things or the higher level things that maybe it's not appropriate to delegate, right? It's like those are the things that we want to keep as things that we want to keep doing.
Yeah.
because it's important to us to have agency in this world as well.
Yeah. Yeah, I think that's a very
Interesting.
nuanced point. Uh, we're almost close, to the end of our conversation, but I wanted to ask this additional question. What are some of the AI products that you like or like following, or some of your friends are working on? What are the problems or like products that you're sort of keeping your tabs on?
Like I think like Cursor one, I use that personally myself a lot. I find it also fascinating to see how some of the major AI companies like Anthropic, Claude is evolving, especially with artifacts and how they're thinking about that, and ChatGPT with voice mode, which is I think not sure they're fully out yet, and search and everything. And it's also very interesting to see how that's evolving. And then I think generally I get excited by things that bring a new way to interact with data or interact with software, right? So I thought like Perplexity, for example, brought a new way to interact with search that I thought was refreshing. Just still it's just like hallucinations and everything, still there, but it's like refreshing, right? It's like a different way to interact with that data. So and then I think there is yeah, some of those are the ones that I come to my mind and things that I pull and use in there. Yeah, and as an engineer, like certainly the cursor there. And I think there's a lot of image and video generation stuff that I find fun from a personal standpoint.
Yeah.
So Suno was really fun. I generated audio clips for my daughter, so my consumer like that she likes stuff, the music that comes out of it. And then it's kind of losing my mind right now. There's one of the video ones that was like generating videos recently that was really good too. What was it called?
Is the FX thing?
No, it's the one that you can put in a image clip, start and end, and then it will kind of like generate the
GIF. Yeah, I
one of
saw
those things.
that.
It's
Yeah. I
dream
know what you're
something.
saying.
I can tell that I played with it a few times and then generate something and then have not gone back yet.
Yeah.
But I think some of those things are also like fun from a consumer perspective to play with, and I think it's like interesting to see, what these things from an entertainment perspective as well, right? They generate very fun things for us to interact with. Yeah.
So I asked all my guests some of the common questions at the end. So I'll ask you them now. What are the things that you're consuming right now? Because what we consume is what we become. And be it Netflix, podcast, books. What are the things that are you consuming?
No, good question there. So let's see. So I'm an engineer. I consume a lot of engineering content, but so I tend to try to compensate with that. So I like Lenny's podcast. You might have heard of him. Lenny.
Yeah, Lenny Richardson.
Yeah, exactly. His podcast is great. In that one, apart from that one, I think I learned a lot from that. A lot of books that as a founder, I'm reading as well, like founder sales and things like this. All the stuff that you might imagine. And then I like to consume. I think I'm on Hacker News a lot as well, so I guess consuming just my regular dose of information from there. I try to stay away from social media as much as I can sometimes because I'm like there's just too much noise going on in there.
Yeah.
But those are the few things I like to consume in there, and I think I'm also a big fan of like meditation type things. So if you know, what's it, Gail Fronstill from Insight Meditation in Redwood City, he's also very good. I like his talks that he gives as well. Yeah.
Nice. Do you use any like apps for meditation?
Let's see, not myself, like right, but then I think like the Insight Meditation Center, like where Gil teaches, they have an app, so they have just like lectures and things that do that. I think it's just good for getting clarity. I think on things.
And who are the mentors who helped your career?
Yeah, no, I met a lot of great people. Andrew, talked about him earlier, definitely. But through my time at Coursera, Daphne Collar was whom I work with closely too. A lot of the early execs at Coursera too, like John Chankudi, Tom Balerer, Jessica Neal, you know, uh, Jeff, I think who's CEO there still right now, worked with him too, like inspired by him. Yeah, there's a lot of people there, and then I think at Google, there's a lot of people in my time there, like Jeff Dean and I chatted a few times. Really aspiring person there, seeing how he works, and all the people I worked at Google, like Kwok, ZF, and so on. Like these are all like great like people I've interacted mentors there, and I think it's a nice diverse group of people. I would say one, but two, I think it's as going through this like startup journeys, And one thing that you learn a lot is like seeing how people react to things and how they think, and seeing how they, like generally one thing I learned a lot was like, I think John taught me a lot, like thinking more like a principles perspective, right? Like what are your first principles when you make decisions and how you think about things in there. Yeah.
And what do you wish you knew when you were starting your career that you know now?
I see. So like early on in my career, I think the one thing I would say is early on in your career, you have a really big opportunity to do anything, like you're just starting off, right? There's this space where you're, I guess, in learning mode. I would say start your career in like voracious learning mode to do as much as you can, learn as much as you can. Because as you go further on in your career, there's this thing that you start to specialize. You start to get good at really something, start to develop skills in a certain area. But until you figure out what you really want to do, I think early in my career, like I learned, I PhD program, I learned a lot of like independent research. But then when I did a startup, I had to put on so many different hats at Coursera, from engineering to design to product to hiring, this and that, all of those things. And I'm doing it again right now, putting on many hats again. And that aspect of learning, I think, really accelerated for me at startups, right? Learning just so many things in there. So I think the one thing I just reflect back on is that I think, just growing up, going through academia, school and all, it's very easy to go very narrow and like get good grades and do projects and everything. But I think it's harder to go like, you know what, I'm here to just learn a shit ton of stuff. And even in your career, like not worry too much about promotions and everything. It's like, I'm just here to learn the business. How does the business work? Different functions of it, right? Learning all of that. So I think for me, like, I was glad to have that opportunity come up for me, and find that opportunity, right? Go out and get it, right? Because they're there, and worry more about, are you learning fast enough, learning enough than anything else. Then later on in life, as you figure out what you want to do, I think there's this natural phase where you go into like understanding what really makes you tick and what really you enjoy doing, and that's when you start to move into a different mode of getting really good at something, or getting really digging into what you really enjoy liking to do. Yeah.
So let me ask one follow-up question on that. What makes you tick? I mean, where do you see that you really tick?
So for me, it's actually like really being at the forefront of what's possible, right? And then I think that for me, that's two things to that. One is like being at the forefront of what's possible, and then also seeing how we can take that and convert it into impact for people. So this was the case for me both at the last two startups, I guess. I was at, right? Being at the forefront of how we do education online and then making it possible to have it. And now was looking at the AI technologies, the agentic stuff, and say, okay, now this is at the forefront of it. But if you look at even AI today, like agents and everything, most of them are targeted towards developers, right? The most agentic frameworks, how the engineers can build an agent, much fewer at helping regular people get their work done, get their things done, right? And so part of my interest in this space is how do we take that technology and make it usable for just a lot more people, right? So that's sort of two things, right? Being at the forefront, I like to see what's new and possible, but number two, making that something that's really valuable and useful for everyone.
Yeah. I mean, I think being at cutting edge or forefront really gives or energizes you in a different way that, walking on a regular thing or something that's already defined doesn't. And that's one of the reasons I'm in the startup ecosystem. And I think that was a good note to end the conversation. Thanks really for coming on the show, and I'm looking forward to use Lutrei.ai more, and I hope it solves all the problems knowledge workers have.
Amazing. Thanks, Nataraj. Thank you for having me on the show. Good to be here.